All right, welcome to the first session of the day. Today's session is going to be centered around LiDAR data and survey applications in transportation visualization. With the advent of CAD tools and other vendor tools that allow better incorporation of LiDAR data into 3D models, we're seeing a lot more opportunities to leverage that data in different ways. And I think we're going to see 4 applications for that. I'm going to let the speakers introduce themselves, and then after each session, time permitting, we'll allow questions for each speaker, and then move on to the next. So with that, I'm going to introduce Ilir Bejleri.
Good morning, everyone. It's a pleasure to be here. I'm an associate professor at the University of Florida in the Department of Urban and Regional Planning, and I'm interested in a lot of things that deal with visualization, but primarily with the 3D and the interactive character of it. So today I will present some work that we did that deals with storm surge and sea level rise. There's other folks that worked with me on this project, so I'm one of the participants. As we all know, when storm surge happens or hurricane or the sea level rise will happen, it will have these devastating effects on transportation networks and the broader built environment. So whether it's a storm surge that has a 1% probability to happen for the 100-year flood event, or if it's a sea level rise, or a combination of both, it's critical to be able to drive that message to the community, because sometimes there's some challenges with that. Because these things are not frequent, they happen every once in a while, and the sea level rise is so gradual, it's hard to grasp that actually it's happening. It's important to be able to use our visualization tools to start to drive that message home, and then help the communities start being more proactive to plan for it. So this study was funded by 2 grants, and we used the Cedar Key in Florida. It's one of the coastal communities as a case study. So we used a number of visualization techniques, starting with the traditional 2D and then moving to 3D to actual physical model and videos of the actual events. We presented this work many times to various forums that involve communities, community events, festivals, other events for quite a while, in several occasions. So from the research design perspective, this is sort of an action research in which we use a case study to be able to develop the finding. From the research methods, essentially is creating the visualizations and then basically collecting data from observations by how those visualizations affect the users. So we looked at questions like, what are the pros and cons of each visualization method? Do they have any synergies across them? How do they connect with the locals? And then what are keys to the effectiveness? So we started with the traditional 2D method. So here you have simply pictures, no storm on the left, and then an actual storm on the right. And then renderings, it's basically take a picture and then Photoshop it to show the impacts based on the future level rise, sea level rise. Traditional maps that shows before and after, in this case the sea level rise affecting marshes from 2008 all the way to 2100, right? And then simple visualization that shows on a top view where the water is going to get to if you have a combination of storm surge and sea level rise. Next, we move to 3D dimension. We started with 3D GIS. We built a 3D model of the downtown area and the portion where the island get access. We used LiDAR to build a digital elevation model, created the 3D topography, and then draped the satellite image on top of it. The 3D model is simple extrusion of buildings, and then layered the transparent flood on top of it. And then based on that, we developed a simple simulation of a storm surge. So this shows a gradual increase of the water up to 11 feet high, which 8 to 9 feet was it was a mean elevation size for the water for one of the hurricanes, Hurricane Hermine. So that's real for this area. So you can see how basically most of it goes in. And the other one is a sea level rise elevation simulation, where we gradually increase the height by 1 foot. So that's 2 feet, and then it gradually, the water's going in 3 feet, 4, and up to 6 as projected for 2100. So we showed these animations to the communities. Next, we looked at 3D laser scanning. We went to and scanned about 2.5 blocks in their main street, generating the 3D point clouds, and then used the elevation from scan to model the buildings, and then the same strategy overlaid transparent flood on top of the model, and then basically developed the scenarios. So that's a picture of the results of the scanning, which looks very realistic. That was one of the advantages of it. And then the video, it's essentially overlaying water on top of the model. So here it's a static view. You can see the realism of the 3D scan, and then the water level going up. That's another section. So when the communities see this, you could see their reaction. It's impressive what visualization can do. I mean, it's sad to see these things, but the advantages of the method are very clear. And then you could do things like that where they would boat down Main Street, which they have done in the case of a previous hurricane. And the fourth representation model is an actual good old physical model. Like anybody who's done architecture knows that, or maybe build other models. So here we essentially took the scan data, carved the base, the elevation, and buildings, we use just the height and then simply build those in plexiglass just because it turns a little more challenging to print them, since the size of them for this scale was more challenging. So we couldn't get the realistic buildings. So instead, what we did is painted the base and then got the facade, the realism of the facade, plotted into a waterproof paper, and then stuck the paper on top of the building faces, right? So we went back to the old-fashioned, and I think the drawback was the scale. They're just too big for a 3D printer. Otherwise, it would have been done completely on 3D printing. So then what we did, we actually have a pump in this tank, and then let the water come in. So here's a video. Well, by the way, the community added some minions in there, made it more realistic. So now, I think whoever was taking this video was moving the camera too much, but it will eventually. So you can see where as the water's coming in gradually, this was the one that had the most effect, believe it or not. Because they could sit around it, it served as a place to socialize and talk about the issues, and it hits home. I mean, they recognize the place. Then the fifth method was to actually relate to something that really happened. So we use videos. So this is Hurricane Hermine, 2016. The water level went up to 8 to 9 feet above the mean sea level. So for this, we basically just showed a video. This has some wind in the background, but we can't hear it. And then people obviously relate to this. So when you show this and then you show that other simulation and they look very alike, they start developing confidence that in science and in these methods and in visualization that, hey, this is really, it's real. So what are the pros and cons? We found that obviously 3D video is so much more positive than the 2D maps and images. You could see their testimonial, like they're saying really informative, the visual make an impact. Wow, what an eye-opener. The laser scan and imagery were impressive, and they included the community character. Now they started tied to their specific place much better. The value of 3D, we saw, the 3D GIS, we saw that it built the whole area, the context, and gave a view of the larger area. The physical model seemed to be the one where everybody seems much more gravitated to. So they thought this was memorable, very informative, interactive. It had a sense of place. It showed a relationship with the water, a gathering place for people to have conversation, and basically inform people about what's basically expected to happen. And the video, we left the videos there in their chambers of commerce where people can, basically walk in, can see them all the time. Some synergies among the methods. GIS provided the elevation data for the scan data, then the laser scan data guided the 3D model with a much more precision, although we didn't really took advantage of all that. The physical model corresponding to the hurricane flooding pattern. And once you have multiple sources of data, obviously we all know that that's a plus, because you could do cross-checking, but it also is a headache to try to put it all together, right? And as we know, to do anything of this dimension, you have to put things together for more than one just software or data source. Let me skip that in the interest of time. But we identify some areas that could be improved. You need to target the decision maker, not just the general public. So that's from the sort of organizational point of view. Sometimes there's this conflation between the flooding method, reasons, whether it's a surge or it's sea level rise. You have the disconnection between a GIS platform and a laser scan. They're all completely separate, right? So you have to bring them together in one way or another. The physical model proved difficult to build, which I explained why, just the scale, but also for this kind of thing, the transport and maintaining it, that's the reason why we all try to do digital. Okay. So, in conclusion, we found that the most successful visualization method had these were some of the key topics of effectiveness. They are relevant, they had realism, they related to the community character, they had interactive components, they served as impetus for social interaction, as well as to create an ongoing communication, and minions. So my colleague, Catherine Frank, she couldn't be here, but she played a big role in this project, and I was part of it. So with this, I think I did it on time. Yeah, perfect. Fantastic. Thank you.
We have a couple minutes for questions.
Yeah, you want to moderate?
Sure. Yeah. I would like a little more information on the source of the LiDAR, and the purpose of my question is the extraction of water topologies in the vehicle, and also detecting overhang can be difficult.
Yeah, those are LiDAR data source. I don't have the technical, the actual technical specs. I think the LiDAR for the topography, but I think it was something that was available from the state of Florida, and that we used that. As far as the modeling of the buildings, and I think you're referring to the topography and how to eliminate the building tops and so on. As far as I know, there is no fully automated method for that, so there's got to be some sort of perhaps a hybrid method where part of it is manual, part of it is basically automated. I think in this particular case, we essentially looked at the first return, and then used the first return only to develop the terrain. And then for the building, as I said, for that particular area, for the downtown model, that was the bigger area, the building height was approximate, which is good enough for this particular purpose. When you need realism and precision, then we used the 3D scan just for those 2.5 blocks. Yeah.
Since a physical
Jason.
model was such a favorite, do you think, but hard to produce, do you think doing a digital version of VR or AR would work with the community in place of it?
I think that seems like the next step to experiment with in addition to this. And I think it should work, right? That's all our expectation, but I don't have any concrete feedback related to the study. But I think that would be the next research question.
Was the average age of the community maybe part of?
A little older, yeah. Well, we never intended to go with the VR. We wanted to experiment with these things, because obviously put the VR together, it's a bigger effort, but that seems to be the next logical step.
Yeah, just to add to his comment, the VR will enlarge your scope. The physical model, like you see few buildings. But the VR, if you have mobile mapping LiDAR, you can, the citizen can visit their houses around their neighborhood. You can't provide all that in the physical model.
Absolutely.
That's a comment. Now, the question I have, can you comment on your finding about the disconnect between the LiDAR and the GIS? What you meant exactly by that?
Basically the GIS data in a certain GIS projection from whatever source, and then the scanning, which is done by some other faculty member that has their own. I suppose they probably are georeferenced, and that's something that I really don't know whether they use the georeference or not. But it's not that, you still need to do some work to sort of put it together. That's the idea. And as far as the virtual reality, that's my next grant application.